Today's meeting objectives, we want to introduce you to basically our Stormwater Master Plan, what the goals are and the objectives of what we're doing, obtain your input, learn about the next steps of what we're going to be doing, and then break up and visit our interactive stations. It's very important that we get your input. We use your input, and I'll show you how, as our eyes and ears out in the field, because who knows best where the flooding is but the residents who live here. I grew up here in Miami. I'm a product of Ransom Everglades High School. The area is very near and dear to me. And with that, we'll get started. The city we're doing a comprehensive stormwater master plan. It's broken up into several watersheds. Watersheds are defined by the topography or where the land is. And we're refining these because stormwater doesn't travel along city boundaries. It goes where the water flows downhill. So it's very important that we capture the full areas of the city where the stormwater, even if it's coming from Miami Shores or from Coral Gables, we need to make sure that we understand where the flooding is coming from. So it's a very comprehensive look at where we're going. Tonight we're concentrating on this District 2, which is Virginia Key, Coconut Grove, Coral Way, Rhodes, Brickell, and downtown. And we've been moving around the city, kind of giving this road show to let everybody know what it is that we're doing and what to expect. Basically, what we're doing is make sure that we have a couple of objectives here. Flood protection, of course. We want to make sure that the city is high and dry as best we can. Water quality for Biscayne Bay and the environment. Checking out land use. We can't just go ahead and pave everywhere and expect the stormwater problems to go away. There has to be some sort of green areas and other things to capture this for storage. So land use becomes very important. We want development to maximize what they can because it's very expensive down here, but at the same time, stormwater management lands must be used and set aside for these purposes for the whole city. Sea level rise, of course, as we had said earlier, storm surge, where the ocean is getting pushed in off the bay ahead of time in front of large storms coming over our seawalls and inundating areas. We want to make sure that we take care of that and look at it with the resilient coastal features, and I'll show you some examples of the things that we were going to suggest. Changes in groundwater levels. It's very strange down here. We let all the water go off during the rainy season as best we can because we're flooding, and then we have a drought during the dry season. So there's ways to use water, stormwater, as a resource. It's something we want to keep down in the aquifer and be able to use so that we don't use our drinking water. And then protection of Biscayne Bay we've talked about, and of course our current and future regulations as these change for stormwater from our regulators. We want to make sure that we're on top of those as well. All of this is basically allowing the city with our mission statement to do a policy framework, get public support, and enhance the city's stormwater and future over time. So we established this vision and the metrics. We got to have metrics as we go with flood control, water quality protection with sampling, aquifer recharge to make sure that we are restoring our aquifer and keeping saltwater intrusion out. Conservation and harvesting is one way to do that. Looking at operation and maintenance, this is a key. If you have an 84-inch pipe and it's 3/4 silted over the last 30 years, it's plugged and you don't need more infrastructure. You just need to clean them and keep your system clean. So that's very important. Long-term financing, obviously you have your bond for our capital improvements program that's out there now. And there's also the element of the stormwater utility that helps fund the maintenance. And then most importantly, community acceptance. We need to make sure that the level of service is something that the community accepts. Is it okay for 364 days out of the year to be high and dry and have that one storm where you're ankle deep for 3 or 4 hours? And that's an important decision that we need to make because it's exponentially more to get that last inch and that last inch and that last inch. And when you're looking citywide and trying to prioritize these types of things, that's where that kind of decision making becomes critical with cost benefit. Our stormwater master plan, we'll see the word called SWIMP. We're in the data gathering and modeling phase right now. And the data gathering we'll show you in a little bit. It's not just the pipes. Okay, what we do when we run these models, which is in phase 2 that we're starting, we digitally rain on the land. And when we do that, we have model parameters such as soil storage and runoff. How much percent is paved, pervious, and impervious? Aquifer storage. How fast is it draining to the ground? Are there pumps? Where are the outfalls? Do the outfalls have head loss? What percent of siltation do we have? Where's the slopes going? Those types of things, exfiltration. So there's a lot more data than just grabbing the pipes. that we're using. And then we go on to doing our actual modeling, and then we also go into the CIP program where we try to solve these problems. And it's not only putting larger pipes in. Larger pipes obviously let the sea level rise come in faster. And when you move water to another area, you're causing a problem elsewhere. So you got to make sure that you're doing a balancing of all the available tools and solutions at your, stand over here a little bit, at your disposal. And finally, for tools and training and policy, like I said before, when development comes in, there are certain things that are going to happen where you're going to have to incorporate stormwater in that, whether that's your seawall height or other things that are going to become policy as we start to move into the future. Most important thing about policy is thinking ahead with our CIP program. We want to make sure that we're looking kind of in the near term, because if we're putting in infrastructure that's going to last 30 to 40 years, we don't want to design out for 100 to 200 years, because what we're putting in will be useless at that time. So you want to make it a dynamic process, and that's part of the stuff that we're looking at. Current ongoing work, you're going to see the guys in the safety jackets. They're opening manholes. They're trying to make sure that what's in the ground is what we're going to be modeling. The main point of this is we get one shot at this, and everybody's got their eyes on this model. We want to make sure that it's right. It's not just good enough to say, yeah, you know what, that's probably a 54-inch pipe, and this is what the best engineering judgment is. We're checking. Developing a flood stage gauge network plan. This is something that's very exciting to me. We're putting stations around. We're piloting this now. So you'll be able to see at certain rainfalls, how high did the water get at 37 different places around the city. And we calibrate the models and validate the models to what that stage gauge is going to, it's real time, and the city's going to have a network so they can see what's happening, and it can eventually be hooked into emergency management and other things such as that. And then of course running our stormwater models and getting these floodplain maps to let you know where the flooding is and how we're going to solve it. And we use those to compare to what you do with your dots today and where you tell us the flooding is, and then we go ahead and we do our CIP improvements from that. Here's where we are today. As you see here, we've taken all sorts of paper plans and we're putting them all around the city, and we're developing this digital stormwater network. And take all these paper documents over here is an example of the halls where we've taken about 30,000 documents and 1,500 other documents, and we've digitized these, and we're turning this into a stormwater GIS electronic network for the city. And you can click on any pipe in there and get all the attributes from it. You no longer have to call the city and they have to look over in the halls and pull the plans and try to get everything's going to be at your fingertips once we're done with this. So that's a huge improvement for what we're doing for the city. The 311 data that we've taken off of the county's 311 and the city's 311 system has been plotted around. We take these, we merge them with the FEMA flood elevations for repetitive loss, and we start doing statistical analysis to predict where we think the flooding is going to be. And then we look at the infrastructure and we see how the two compare, and we figure out what the problems are in those areas based on this data. And we've already taken the first two sets of data when you put your dots on your flooding area, and we bring those in as well. There's different dots you'll see in here for different types of flooding, and we're using those data to start doing some statistical analysis to make sure that we're in the right place and we're on the right track. We do these heat maps and we kind of put all these things together, and this is eventually what it turns into when we start superimposing things. So we'll have maps and things like this that we will study to make sure that we are in the right place and we're on the right track. Here's an example of the first models that we started. If you can see this over here, this is the Shorecrest area. Shorecrest had the most data, so we were able to start over there. All those little dots are subbasins, so those big watersheds then get individually carved into smaller and smaller on the neighborhood level. We put in all the pipes in those areas. This is a digital model of what the stormwater model actually looks like in a screenshot, and it's pipes and nodes and storage elements and all sorts of other input data like that. And then this is the output, and it tells you exactly where the flooding is. And this one happens to be Irma with tidal flooding and with the rainfall on top of it. The depth is under different colors, and then we put in our capital improvements, we run it again, and we see where we've solved the flooding. So that's kind of the process that we use with our models. Most importantly, level of service. 3 levels of service here. Obviously, we want to make sure that we keep water out of the homes. That's the most important thing, to make sure that we keep water out of your homes, make the roads passable for emergency vehicles. And then from that, there are ways where the level of service is a policy decision. Is it okay to have it ankle deep once in a while if you don't have the funds in place, and where are we going to be doing different types of improvements? So that's the type of analysis that we do with level of service. Sea level rise considerations. This is the South Florida Compact. Everybody's probably familiar with this by now. The data they have over 30 years, I believe, was about 9 inches of sea level rise so far. And they have the high, the medium, and the low. And what we've done is chosen two, the 30 inches and the 18 inches, so 2.5 and the 1.5 feet. And this is where we are going to start doing our analyses. So once we run our rainfall, and we do that at high tide, then we superimpose what happens in the future at this level or this level, and then we can start doing different scenarios for that. What would it cost if? And do some cost benefit analysis, trying to get the inundation of the areas down to a minimum. This is an example of some of the things that may end up on the shoreline that some communities are doing. This is armoring of a mixture of green and gray infrastructure, where you have a sacrificial area here that all is walkable except during a storm surge. And then you have a nice barrier up here, and this is where the actual berm starts. So these are the types of solutions. Other things, making sure that you either relocate critical infrastructure or raise the critical infrastructure. You might be paddling out to get there, but things like the electrical substations and the treatment plants and other hospitals and things, as long as you can get there in those roads, those types of things, they can start to be raised for those finished floor elevations. And usually it's a combination. The last resort obviously is relocating areas, but some low-lying areas may need to be relocated. And that's just going to be part of what we're going to look at. And again, policy decisions will come into play with that. But it's going to be a combination of all of these. Green infrastructure for multiple benefits. I know we harp on these a lot. So you see these little things. It starts at the house level. So if you have cisterns and if you have rain gardens, you say, well, it's just a drop in the bucket. But if everybody does it, and then on the neighborhood level, we put in these parks, these passive parks. These aren't just, hey, we just put some grass over. They come down to the top of the aquifer. We look at transmissivity, their engineering design, and we get the water to these. You put a couple of these, and you have a neighborhood. And then in the park area, for a larger group of neighborhoods, you can put additional. And then, of course, the infrastructure that we put in citywide. So it all builds synergistically upon each other. This is good for water treatment. It is good. Everybody has to capture their own. And if we make that part of the building code and we capture the storms as they come, less runoff is going to come out for the whole city. And then that's the main steps to having that built up synergistically. So where are we now? We're still in the data collection phase. We're out there. Like I said, you'll be seeing those. We're starting our pilot projects for the flood stage gauge network, and you'll see these around. We're going to have a nice sign, and you'll be able to see the implementation of that. Then we're setting up our models. Like we start from north to south, mainly because that's where we had the most data, and we're trying to do this as quickly and as efficiently as possible. And we'll be heading south, so we'll be coming down in this area. You'll start seeing the surveyors shortly as they come around, to make sure that we have the correct pipes and other things in the ground. Then we get our infrastructure recommendations. Once we get those recommendations, we do the cost-benefit analysis on those, and we see where the money can best be spent. We do prioritization. The most important thing is to realize if you're flooding in your neighborhood and you don't see a project in your neighborhood, and someone else is having a project, it's probably because your flooding was caused by something upstream. And we're looking at that. So it's not like you're being left out. We're looking at the whole city synergistically and holistically to make sure. So if there's a project upstream of you or in another surrounding neighborhood, it may just be we're not being reactive, we're being proactive, and we're out there trying to stop the water because we've noted that that's where it's coming from. So there's a lot going on there, and you'll see these projects coming around, and you can read why we're doing what we are in the final report when that eventually comes out. Policy guidance and design standards, of course, once we get this, how high will seawalls have to be in the future to keep the storm surge out and other issues of how much you have to capture on your site and other policy issues such as that will be coming out. And of course, tools and training. We're going to fully teach the city's operators how to use these models so that when additional pipes come in or new developments come in, they can be able to change these pipes and see what the effects are on small projects and large projects. So it works on both. So with that, we'll turn it back over to the city and we'll talk a little bit about the bond.